New set of notes, today is the 13th. So it's a separate set of notes from the other ones that we just got done going back over. Trapezoids, we're going to cover trapezoids. I'm going to add a slide to this slideshow so that we can finish out the chart. So read that real quick so you got an idea why I shut it down.
You can freeze it and then add stuff back there. I can't. Oh, with yours you can.
One way the computer set it.
Oh.
Alright, so again, a trapezoid. Be able to use properties of a trapezoid, be able to give a quadrilateral the best possible name. This, after these, you're going to know all the quadrilaterals, so this chart over here will be finished. I'm getting ready to draw it. Again, you probably want to draw this somewhere in your notes. Probably the one that I'm going to draw on there will be the same thing. What happens here? A trapezoid. Here in the last year or so, they've changed this. It used to be that I put a trapezoid right here. Now, a lot of the math gurus are saying that instead of a trapezoid being its own branch out there off of quadrilaterals, it should actually go right there. So we should have done it before a parallelogram. And I'm going to show you why when we get to the definition here in a minute. Now in this chart, there's going to be another shape that we're going to put here, and there's going to be a shape that sort of comes off of a rhombus there. It's a rhombus and a square, but it's not a rectangle and it's not a parallelogram. So it's sort of, it's like a growth maybe that you have on the side of your head. It's not really anything. Right? Yeah, you got a growth on your head, don't you? No. You got a growth on, it's on your shoulders, I mean.
What's your head?
He looked to make sure that's the funny thing.
Listen to Derek, because she'll tell you.
What's your head?
I'm worried.
All right, so on this chart, again, draw this chart. You have quadrilaterals. You have quadrilaterals. What is a quadrilateral? Four sides. Off of quadrilateral, we had what? Parallelograms. Again, we want to hurry and get through this. What key idea about parallelograms? Both pairs of what?
Sides.
Opposite sides,
Parallel.
parallel. Both pairs of opposite sides have to be parallel. Off a parallelogram, we had a branch that went to what? Rectangles. What was the key idea about a rectangle? 4 right angles. Off a parallelogram, we also had what else? Rhombus. 4 congruent sides. And then off of those two went together, we said it would be a what? Square, good. It's got 4 congruent sides and 4 congruent right angles, or 4 congruent angles, right? If they're all 4 congruent, then they have to all be right angles. So again, make sure you got this chart in there so you can refer back to it at some point. Again, I usually put trapezoid right here. But now they've changed the definition of it by one word. And changing that one word sort of changed everything on it. Alright? So trapezoid should actually go right here. Anybody have a guess as to what the other shape coming off a trapezoid might be? Let's keep that guess in mind for here in a second.
That's what's gonna go off on
Isosceles, isosceles trapezoid. Guess what an isosceles trapezoid is? What's an isosceles triangle? Two sides, a triangle with at least two sides congruent. Guess what an isosceles trapezoid is? Trapezoid with two congruent sides. The one that comes off a rhombus here. What is it? Kite. We won't deal with the kite a whole lot. It's sort of the, yeah, it's sort of a loner that really doesn't have a whole lot of properties, doesn't work out real well with all the other stuff. So that's our whole thing. Now, a trapezoid. The key thing for a trapezoid that we should write out here, and you'll write it out here in a second, is sort of like a parallelogram, except instead of both pairs of opposite sides being parallel, guess what has to happen? Instead of instead of both pairs, opposite sides being parallel, one pair of opposite sides are parallel. And I'm going to put the definition up here now. This is the definition of a trapezoid. The word that they left out now in the definition is this word. Instead of saying it has exactly one pair, now they're saying it has one pair. So what else could it have?
it actually
Could have two. And if it had two, we wouldn't call it a trapezoid, we would call it a parallelogram. So that's why trapezoid would go here. Then all parallelograms are trapezoids, but not all trapezoids are parallelograms. So that's all. They changed the definition by that one word. Got rid of that word, and now it sort of falls in a different spot, sort of. Still the same idea. And apparently, all other countries, I don't know about all other countries, but most other countries have always used this definition, and that's why the math people in the U.S. now are trying to sort of switch to that. I'm not sure why they're worried about a trapezoid and they're not worried about the metric system. Because I wish we were on the metric system. That'd make a whole lot more sense. All right, draw, not this one. I'm going to go to the next one. Draw this trapezoid. Some of the stuff that I put up here, I'm going to put a bunch of stuff up here and we're going to label this trapezoid. Draw it big enough where you can put a bunch of stuff in it. So make sure, sorry, I probably should have said that first. Make sure you make it big enough where you can put a bunch of symbols and everything else in it. Still with us, Bryant? Still with us, Bryant? I heard you say, I didn't see it. Start moving around like you're still with us.
I didn't do such thing. Yeah, I think Brian's next.
This?
Yeah, Dad.
Remember last time, where did you see that?
It's out that door and sitting right there in the hallway.
Down in Mr. Fisher's office?
It could be there.
Is that what you want it to be? Because then I gotta write it up and call the house and go through a bunch of headache.
I don't
You don't care? If you don't care, I can stop this and we can take care of it.
care.
If we could stop this.
We're shopping what, class?
For now, for the two.
Oh, if this is just temporary, then you might as well just go on.
We can make it permanent, and I'll have a talk with him. See, you think this is funny, and I don't. I'm not laughing. Because if you're gonna, we could,
You can continue.
thank you, I'm glad you allowed me to do that. The first thing, segment AD and segment BC. So on this, you should have labeled it. Again, you gotta be moving quickly and you gotta be writing stuff down as I'm doing it. Those two are called bases. Now normally, because when we had a triangle, we just had one base, right? So we don't get these bases mixed up.
Base one, base two.
We call them like base 1, base 2. Very good.
We did this last year.
Did you?
Um,
So base 1, base 2. Those two are always parallel to each other. So put that in your drawing there. Again, some of this stuff up here, maybe you don't have to write it down because you're putting it in the drawing. Depends on which way is going to make it easier for you to remember when you refer back to it. Maybe you do need to write it down. Next thing, AB and DC are called the legs. So this is a leg. That's a leg. Just like in an isosceles triangle. What was this side down here at the bottom called?
base.
It was called the base. What were these two sides called?
Base.
Legs. Does anybody remember what these angles right here were called? If I could ever hit them.
Vertex.
The other two.
Oh.
That's the vertex angle up top, right? Those two were called the base angles, and that's what these are called. Those are base angles. Those are base angles. And we're going to talk about those on the next slide. Now I drew in this extra segment going across here, segment EF, because that's something special. What's it look like point E is there? Midpoint. I would write that right there. E is a midpoint. What's it look like F is? Midpoint. Now that segment is special. It connects the midpoints. Have we ever talked about a segment that connects a midpoint to something? When we were dealing with those triangles, which one connected a vertex to the midpoint? Which one connected the vertex to the midpoint?
That one. Oh, central.
Not centroid. What was these called? They were medians. Guess what this one's called? That segment running across through there. It's a median. That's what it says. It already popped up. So EF is a median. This you might want to make sure you write down. This is very important about a trapezoid. Connect the midpoints of the two legs. It's called a median. Now, give me one thing that looks like it's true about segment EF, that median.
20.
So I guess. Give me something else. What can you tell about the two bases in it?
They're parallel.
They're all parallel, so you might want to put another parallel. All three of those are parallel. That's one of the things I'm going to say here in a minute. The other part. Median's always parallel to the bases, and its length is equal to 1/2 the sum of the bases. I'm going to write this equation down up here. I highly suggest that you write this equation down for this next to this one.
Isn't it base one plus base two divided by two?
Now, it's not because of what you're thinking, but yes, it is. The median equals base 1 plus base 2 divided by 2. So if you're looking for the length of the median, you can find it just using that. So let's do this. If I told you base 1 up here was 25 centimeters, base 2 was 15 centimeters, could you find the length of that median? 20? How'd you get that?
You add them together and then,
25 plus 15 is 40. Divide that by 2, you end up with 20. All right? What should always be true about the median in relationship to two bases?
it should be parallel.
That's true, but what about the length of it? Should be in between them, shouldn't it?
Yeah.
So if one of these is 15, one's 25, the base has got to be somewhere in between 15 and 25. So if you came up with the median being 70, you know something's wrong. All right? What if I did this? Let's get rid of those two. We'll leave that one 15. What if I told you the median here was 18 centimeters?
You can figure it out.
Could you find the base?
Yeah.
How would you go about doing that?
You have to put base 2 in there, and you find the median in there.
Alright, so you could use the formula and use it backwards, right? What's median?
18,
18 equals, what's base 1?
X, question mark,
Question mark or x plus what?
15,
15 divided by 2.
times 2 both sides.
Times both sides by 2, then do what?
Minus 15.
Minus 15. Now, if you do a couple of these, instead of doing that every time, you might find it easier to go in here and take the median, multiply it by 2, and then just subtract off the other base, and whatever's left is the base that you're missing. What is it? Let's try it up here. What's 2 times 18? 36. X plus 15, what do I do there? Subtract 15.
21.
What's x? So that side would be, that base would be 21. So make sure you got that formula down. Next, just write this down. That's all you gotta write down. Isosceles trapezoid, and draw that picture real quick. We're gonna label some stuff on it. So this is an isosceles trapezoid instead of just a trapezoid. And I probably should have said this on the other slide, because every trapezoid I've had up here has all looked the same, haven't they?
Yeah.
This is another way a trapezoid could look,
It's like half a trapezoid.
where these two sides are parallel. This is another way a trapezoid could look. Alright? So don't get stuck. As long as they have one set of parallel sides, it's a trapezoid. Don't get stuck thinking every trapezoid has to look like the ones that I put in here. The only reason I put those in here is because that's what the computer will draw for me. Alright? An isosceles, so not every one is an isosceles trapezoid. On this isosceles trapezoid, a few things. Number one, the legs have to be congruent, so mark those congruent. What do you still know about the bases? They're parallel. Now, in an isosceles trapezoid, what looks to be true about these two angles? They're congruent to each other. Those base angles are congruent. Guess what's true about these other two base angles? They're congruent. So we know all that about an isosceles trapezoid. There's actually a little more here. Oops. Hit the wrong, I hit the wrong thing. Did everybody get that before I erased it?
Yeah.
So we know these two are congruent. We know these two are parallel. We know these two angles are congruent. We know these two angles are congruent.
Do you mind while you're talking? I will freaking.
Do what?
It won't make any work. I think.
If I draw in the diagonals, my diagonals might not be drawn real well. Do the diagonals bisect each other? Is the distance from here to there the same as the distance from here to there? No, so unlike a parallelogram, diagonals don't bisect each other. But what looks to be true about these two? They're the same. What looks to be true about these two? They're the same. What's true about these two angles right here? They're the same also. So that angle's congruent to that angle. What kind of triangle is this triangle right here on the top? Isosceles, good. What kind of triangle is this triangle on the bottom? So what do you know about these two angles then? They're congruent. Alright, now does that mean, do we know everything else? Do we know that this angle is congruent to this angle? No. The other thing that we do know, these angles that are consecutive angles, sort of like a parallelogram, guess what has to be true about them? They add up to 180 degrees. You might want to make sure you write that down. That's sort of important about a trapezoid. That works for all trapezoids, not just an isosceles trapezoid. These angles add up to 180. Guess what's true about these two angles? Add up to 180. Now, does that mean that this one and this one are going to add up to 180? No, it's just a lower base angle and an upper base angle. So lots of stuff there. Last thing. Oops, that's not what I wanted. This just says what we just wrote down there. Isosceles trapezoid have base angles that are congruent. Diagonals, they don't bisect each other, but they are congruent to each other and they split each other up sort of the same. The last thing, a kite. This is the definition of a kite. Quadrilateral. With two pairs of disjoint, now you don't know that word, but disjoint congruent sides. I'm going to explain it.
That's two parts or two pairs.
Two pairs. If I draw this picture, man, it was not getting right. If I draw that picture, and these two sides are congruent, and these two are congruent. What it means by disjoint. If I was to cut this kite right through there, I have two congruent sides here and two congruent sides here.
Good afternoon, everybody. Time for a couple
Does that work with a parallelogram?
First
No.
of all, good luck tonight.
Alright, so that's a
Our
kite.
softball team, as they will have a home game tonight versus Centerville, Indiana, here at 5 o'clock.
That was a
Also, our
question.
JV baseball team, as they will travel to Franklin Monroe for a 5 o'clock game. We also want to wish congratulations to our varsity baseball team, who are now 3-0. They defeated Seton Catholic in 6 innings, 11-1. Charlie Walker.
This is the other part of the assignment.
Go Blazers.
Make sure you do
Next
both
home game
parts.
will be tomorrow for our varsity at 5 o'clock versus Ansonia.
It will be collected next time, so make sure you write that down. 434 and 442.
Rest of your Monday. We'll
Finish
see you back here tomorrow. Thanks a
434,
lot.
do 442. Both parts. We got what, 10 problems done of the other one, so there should be about 22 or something like that total problems. 21, I don't know, something like that.
Sharon, so do you have a brand? Or it's good for you, will be one of those.
That assignment will be collected next time. Both of them.
Okay, I will. All right, I'll try it for you.
That's enough book in here. That's enough book in here. No, it is.
Been nice if he returned it to me though, since I like used it. Probably why.
See you tomorrow.
Yeah. I seen you again, reminded me I still gotta check on that. That slope.
Last couple hours.
Yeah. Might not last that long. Valley hasn't played any of it, not very good, so.
Yeah, I'll see if I know I got. Would you be like standing out in the outfield?
Probably. Stopping somewhere on my way over there. Been a long Monday.
Yeah.
Get out there. Tell you what, if I was that close, I think I would be doing it.
You got 25,000? I had 25,000.
I'd probably take out the loan or something, just so I could get out. All this stupid crap. And the kids, I don't know, just.
Well, the only thing. I really do. All this standard stuff, Common Core, I don't do it. I just don't get it. I mean, I'm gonna teach just like, you know, your captain, cover the whole book. And that's not. I'm already in, I keep covering stuff.
Speaking of Common Core, that's something we haven't heard for 6 or 8 months. Yeah. And the bad thing with that last teachers meeting and with the park, they're starting to, that's what I think too, that they're starting to sound like, oh no, it's gonna stay around. I'm thinking, the only reason you're saying that's because everybody bitched at the moment about it. Everybody was bitching.
Website stuff, as soon as all this actually testing comes up,
More and more of it.
I don't know if it'll go away, but I bet you that's coming back. They're gonna fit this testing. They're gonna do one or two things. Testing down. Yeah, expect to get at least 20 days a year of
It's just,
testing and then expect to teach the same amount of stuff.
I don't even know the same amount, and they're expecting more, I think, and, well, some of it,
Yep.
some of the crap is, like the park, you know good and well that the only reason some daggone lobbyist. Yeah, there's a bunch of people, cause that, why did they pick the park test over the 6 million other tests that were out there? And, you know, what's so special about it? And the math test, any of what, you know, what's. Exactly.
We would be rich.
Some
We're the idiots.
state congressmen got their pocket lined, and now the people at the testing places are getting their money from us through the taxes and everything else that the schools are paying. So it's a big circle there where they're all getting money and. Get screwed. He has a.
There first, he was, what's their money now?
Today when I talked to him, he was acting more like, yeah, if I'm going, you know, before when I talked to him, it's always been,
I'm going.
yeah, after, so I don't.
seriously? I don't want to do it. I can tweak what I have, and I've been teaching counseling. I can't walk in there, and that's, you know, you should have this lesson on each other. They can't walk in there and just teach the rhythms and vibration of the line. You know, I mean, after 32 years of this stuff, if I can't walk in there and teach it, something's wrong.
I don't know, a couple years ago, they talked in one of those, who we had as a principal, we might have still had Clockberg. But one of the in-services that we sat through, the speaker said, oh, you need to switch up your classes every couple of years, you need to, yeah, and I'm thinking, no, let me get used to teaching this, and then I can see the little things where things are wrong and what the kids usually understand and what they don't understand, and I can make sure I come. How does it make sense to flop me back and forth every couple of years?
So it's like today, when I was teaching this review, you know, we're gonna work on it out. I said, these guys back here grew up, and I learned here and all that. You guys better be paying attention, cause this is where one of you are gonna screw up. I said, here, they give you the problem in inches, but the measurement for the work is foot pounds. And then it was 10 minutes. Where did 1/2 come from? Well, remember 10 minutes ago I told you, 6 inches is 1/2 a foot. You gotta get to the same unit. But I mean, I teach it, I said, this is what you gotta watch, because this is where I have mistakes every year. And that's just
It doesn't make any sense to me, why
more
even,
and more Parker and Fisher just administrators.
why would they wanna do it? Cause, I mean, it doesn't make sense to me why they wanna do it, because that just makes more work for them too, to switch up the schedule. Why not just leave the shit alone?
It's just like the white day. Everything was fine on the block today. Fisher come in and said, oh, I gotta change this because I gotta improve.
Okay.
Well, it doesn't improve it. But in his mind, he tells you, Aaron, they think they gotta do something to put their brand on the product and so that they can say, oh, I did this, I did this.
I tell the kids all the time, Pythagoras is the only one. You see all these other theorems and everything, and he's not the only one. You know, there's others also, but not in geometry that we get to. Most math rules and stuff don't have names. They're named what the hell they should be named. Like the midpoint formula. You find the midpoint, use this.
Distance formula.
Exactly. They don't make up stuff just because somebody wants to put their name on it. They don't call it something stupid. Exactly. Don't call it something stupid just so that, hey, look at me, this is my, you're right, with Fisher changed it to the white name. Oh, look, this is what I did.
Yep. Every one of them has this real complex. Never seen administrator like that. Never seen one that did. That's how I always got away with getting the way I wanted with her, because I let him take credit for everything. If you let him take credit, he'll let you do whatever he wants. And stand up there and brag, oh yeah, we're doing this. You know. As long as he can take credit, pat himself on the back, he was happy to keep working. He sat up there and drank beer, here, as long as he got credit for something that he could run out there and tell everybody he was doing.
I got these stuff to grade. I'm gonna try and get it done before I don't even think I'm gonna go home. Just head straight over that way, so I'll get something done here. Plus, I gotta look at that slope. He's probably gonna come up here yelling at me if it's not approved. I didn't even hear. No, not really.
That's why I'm kinda, I asked him the other day, like, we gotta do, this is you can assume that.
Kids, I'm always messing with me with this stupid thing, and Mr. Fisher, you're like, I don't care. He's been nice, so he yells at me, I'm not like it, I'm not like I'm 5 and I'm gonna cry or something because he yelled at me. I'm a grown man, let him yell at me, I still do, and all I care about is I do my job in here, what I'm supposed to be teaching you guys, that's what matters. Stuff like
Here they drink coffee. Have water, not have coffee. Do I really care if there's a letter in our notes since we started drinking this coffee? Do I really care? Put that letter in my file. I
Yeah.
don't care. Okay.
that makes sense.
Yeah, that's, I tell you what.
Poppenberg, I bit my tongue. He jumped all over me one time when my mom passed away. And I told him I was gonna be out for a couple of days, and ended up I had to be out for a couple more days after that. And when I came back, freaking be out like that, about it, have lesson plans, everything else I heard, and he was going off. And I just, I said, all right, I'm just, I apologize. I walked away because I thought, that dummy bastard. Don't, you don't jump on me like that. I'm not your kid. I'm not something.
It's like Harrison at Harvard, he collapsed on. He called out one time. Well, I told him, get your things, so I did. And I even told him, I said, you know what? Look at some lesson plan. I'm laying in the hospital. When he saw me, I had that thing, that's how stuff. And I said, you know what? They're gonna give me some more morphine and I'm not gonna care. What do they expect me to do?
Yeah.
Really? You're not
And that's what I told him after a couple.
Okay.
After a day or two, when I thought, just shut up and walk out the door, don't. And after a couple of days, I walked in and said, can I talk to you? I said, now I know I didn't have lesson plans here, but in the middle of all this stuff, I couldn't really just take off and come in here and make up stuff for you. So I apologize for not having it there. You know, but it was like over a weekend, and I was out on like Friday, and then I had to miss a couple of days the next week also. And I said I couldn't just take off and come in here and make up those extra lesson plans. I thought I was only gonna be out a couple of days, ended up turning into more. Oh, you can't. And I said,
He knew whatever he wanted to do from there. And that's just stuff out. Just